Hello class, this is section 6.2, more on trigonometric equations. For this first equation, we need to rewrite secant as 1 over cos. And now we can multiply both sides of the equation by cosine to get rid of the fraction. Notice that these will cancel. And on the left side we get, we're going to get 2 cosine squared x minus cosine x equals 1. Then we subtract 1 over. We get 2 cosine squared x minus cosine x minus 1 equals 0. And then we can factor this equation into, alright, since we need a negative cosine in the middle, that means the outer should be negative to get negative 2, and the inner should be positive to get a positive 1 cosine. Then we set these two factors equal to 0. When you set the first one equal to 0 and solve, you're going to get cosine of x equals negative a half. The second one is going to be cosine of x equals positive 1. Looking at your unit circles, you should get x equals, for negative a half, let's see, that would be this one, which is 2/3 and 4/3. 2/3 and 4/3 pi. X equals 2/3 pi and 4/3 pi. And we don't have to add the 2 pi k because they're giving us an interval to work on. And these are the two answers for this equation. And then the answer for this equation would be 0, because that's where cosine is equal to 1. And that does it for that problem. For the next example, all right, this one is a little bit more challenging because you have sine and cosine. And in order to get everything in terms of cosine, you would have to rewrite this in terms of its double angle formula, which is 2 sine theta cosine theta, radical 2 cosine theta equals 0. Then notice that there's a common factor of cosine, so we can factor out a cosine. Get 2 sine theta plus radical 2 equals 0. And then you set these individual factors equal to 0. And the other one, this one, if you set this equal to 0 and solve for sine, you will get sine theta equals negative radical 2 over 2. And this angle, cosine has a 0 value at angle 90 degrees and 270. And sine has a value of negative radical 2 over 2 at, what is it? Let's look at our unit circles. It would be in the 3rd and 4th quadrants here, which is 225 and 315. 225 and 315. All right, and that would do it. Let's look at the homework. All right, we're going to go down to problem number 3. So for this one, we're going to have to write cosecant in terms of sine. So that's going to be radical 3 over sine theta. And then subtract 7 to both sides, you're going to get negative 2. All right, and then if you multiply both sides of the equation by sine, and then you're going to end up with radical 3 equals negative 2 sine theta. Divide by negative 2 sine theta is equal to negative radical 3 over 2. And that would happen in 2 quadrants. Negative radical 3 over 2 would be here and here. So that's 240 and 300. 240 and 300. All right, for the next example, we have to use our double angle formula. So sine 2 theta is 2 sine theta cosine theta. So I just substituted for 2 sine theta. And now I have plus cosine theta equals 0. Once again, we can factor out a cos and get this equation. And then you set the individual factors equal to 0 and solve for sine. In this case, you get negative 1/2. And so the answers are going to be cosine is equal to 0 at 90 degrees and 270. And sine is equal to negative a half at, that would be, what is it, 210, I believe? Yeah, 210 and 330. 210 and 330. All right, there it is. For the next equation, we're going to use the double angle formula for cosine of 2x. If you recall that one, we can go to our trig formulas and look at those double angle formulas for cosine, and they are down here. There's 3 of them to choose from. We want to choose the one that doesn't have a cosine, so it would be 1 minus 2 sine squared. 1 minus 2 sine squared. X, not theta, minus 3 sine x minus 2 equals 0. So I just replaced the double cosine 2x with its identity. And now we can combine like terms. 1 and negative 2 make negative 1. I just combined these like terms. All right, and now I'm going to divide everything by a negative 1. And that'll make everything positive. Now we have a problem that can be factored, an equation, so that's going to be 2 sine x, 1 times 1, and you need these both to be positive in order to get the 3 sine x in the middle. All right, if you set these factors equal to 0 and solve, you're going to get sine x equals negative a half for the first one, and sine x equals negative 1 for the second one. So just as this equation up here, we got 210 and 330. And sine is negative 1 at 270. So that would do it. Oh, but these are in radian. So these are the same answers, they're just in radian form. So just look them up and you can get those answers. All right, the next one, we need to convert cosine squared into sine squared in order to get all the trig functions to be the same. So I'm going to use the identity cosine squared x equals 1 minus sine squared x. And that's going to become that. And then we distribute. It's going to be 2 minus 2 sine squared x minus 3 sine x minus 3 equals 0. After combining the like terms, you should get negative 2 sine squared x minus 3 sine of x minus 1 equals 0. Divide everything through by a negative 1, and they all become positive. And then you factor, and it looks like the same equation we had in the previous problem. Yeah, it is. So the answers are going to be exactly the same as before, because these are the same. This is the same trinomial that we had in the previous problem. For the next one, this one's a little bit more challenging. So for this one, we need to, because there's no identity that we can substitute for, we're going to have to square both sides. But first, let's get the cosine on the right side. So this is one of the techniques that you would use when you can't use an identity. So you have radical 3 sine theta equals radical 3 minus cosine theta. Then you have to square both sides. So when you square this, this becomes 3 sine squared theta. This becomes 3 minus 2 rad 3 cosine theta plus cosine squared theta. You can verify that. I just multiplied this out by foiling. All right, and now we can, what would we do in this situation? Looks like we're going to have to replace this with 1 minus cosine squared. All right, distribute. All right, notice that there's 3's on both sides, so when you subtract 3, they cancel. And then you can add 3 cosine squared theta to both sides. So you're going to end up with 0 equals 4 cosine squared theta minus 2 radical 3 cosine theta. And then you can factor out you can factor out a 2 cosine theta, and you're left with 2 cosine theta minus radical 3. And then when you set these two equations equal to 0, you're going to get 2 cosine theta equals 0. And this one, when you set it equal to 0 and solve for cosine, you get cosine theta equals radical 3 over 2. So theta would be, for this equation, you would get 90 degrees and 270. That's where cosine is 0 for cosine. And then for this one, you would get the two angles for that would be cosine is radical 3 over 2 at 30 and also at 330. So 30 and 330. And there are the answers way up here. Oh, but we need to check. I forgot to mention, whenever you square both sides of an equation, there's a possibility that your solutions will be extraneous. And so what you have to do is plug this into the original equation to see which ones check out and which ones do not. For example, let's check 90 degrees. If you plug in 90 for theta, you're going to get 90, that would be 1. This would be 0, and so you get a true statement. So 90 is a solution. If you try to plug in 270, so sine of 270 is -1, so that would be negative radical 3. And this would be 0, and as you can see, that is not a true statement. So that's extraneous, and the same thing will happen with 330 apparently. All right, the final two problems will be, all right, so here we have to use a half angle identity, which is plus minus 1 minus cosine theta over 2 minus cosine theta equals 0. Then we add cosine theta to both sides. We're going to have to square both sides of the equation again. Plus minus 1 minus cosine theta over 2 equals cosine theta. When you square both sides, that means we're going to have to check for extraneous solutions. The square and the square root will cancel. The plus minus goes away because whenever you square a number, it becomes positive. So you get 1 minus cosine theta over 2 equals cosine squared theta. Multiply both sides of the equation by 2. And you get 1 minus cosine theta equals 2 cosine squared theta. Bring everything to the right side. You get 2 cosine squared theta plus cosine minus 1. All right, factor the trinomial. 2 cosine theta, 1, 1. You need a positive cosine, so that would be the factorization. The first equation would be equal 1/2. The second equation would be equal to -1. And let's see, the angles for this one are going to be, cosine is a half at 60 degrees and also at 300 degrees. And cosine is -1 at 180. And because we squared both sides of the equation, you have to check for extraneous solutions. So you would plug these into the original equation to see which one is true and which one is false. Turns out that 180 is going to be false, but the other two will be true. All right, for the final problem, for this one, we would have to, all right, it looks like we're going to have to, it says use a graphing calculator to find all radian solutions. So what I would recommend is just go to desmos.com if you don't have a calculator, a graphing calculator, and type in this function. Type in y equals cosine x plus 4 sine x minus 2. Don't do the 0 part, just y equals. So type it in exactly the way you see it into desmos.com, and you will see wherever the graph intersects the x-axis. So your graph might look something like this. Who knows what it looks like? But there will be solutions. If you click on those x-intercepts, those will be your solutions. So you only need to look between 0 and 2 pi. And so